Hello, welcome to the latest episode of Data in the Hallway. My name is Ray Paik, Community Manager for TiDB. Honored to join today by Sorin Dumitrescu. Hopefully I'm pronouncing your last name correctly, Sorin. He's a CTO of Omniconvert, and I had a good fortune of meeting Sorin in person. We're recording this in the second half of February in 2025. A few weeks ago, we're all in Brussels for FOSDAM and had a good fortune of meeting you in person, Soren. Um, I try not to take that for granted. Like we work with a lot of our community members like virtually, so meeting somebody in person, it's I really relish that. And not only did I meet you, but you're one of the presenters in the cloud native databases track. So it was great to have you share your experience of migrating to TiDB. Welcome, Soren. Yeah, so I mean, to start off with, I'm not sure if a lot of people are familiar with your company Omniconvert. So tell us about what Omniconvert is and the type of data that you're dealing with on a day-to-day basis.
Sure. So, hello, Raymond. Very glad to be here. It was also a pleasure meeting you and the TiDB team in FOSDEM. With regards to Omniconvert, we're a fairly small team. We are building and operating two SaaS products. One is for conversion rate optimization, which essentially means turning visitors into customers. And the other one is for picking up where the CRO part left and essentially turning one-time buyers into multiple time buyers. And this is called customer value optimization as a concept, let's say. We're typically dealing with a fairly high traffic application with requests around 20K, 25K per minute during the day. So we ingest all kinds of events related to experiments. The conversion rate optimization is done through A/B testing mostly. And this amounts for a lot of data collected for tests, like user interacted with an experiment, clicked on that, waited that long, then made a conversion, stuff like that.
Cool, cool. Yeah, so I think you're helping. I mean, a lot of people, all companies, like uh, dealing with the common challenge of turning visitors into a customer, or and then have them keep coming back. I mean, that's a obviously common challenge that everyone has. I mean, including us at PingCAP as a company. Like we want to make sure that if you read the blog post that you come back for more and then turn them into a sort of a repeat visitor. So yeah, so obviously you're dealing with a huge amount of data, like you said, and then it sounds like you're also doing a lot of different testing too to sort of optimize the visitors. And obviously, I mean, I don't think I mentioned this. The topic of your talk at FOSAM was, I mean, there was a very catchy title, migrating 3 billion rows to TiDB. So you had to migrate a massive amount of data to TiDB, and then we'll get into detail of what you went through. So, what database were you using before TiDB, and what sort of led you to look into looking at different options to migrate away from your previous solution?
Yeah, we were using a pretty old version of MongoDB. It was MongoDB 3.4. This, on one hand, ended support in January 2020. So, 4 years before we started looking at the migration, this was one of the reasons, which was more latent, let's say. But the main struggle that we had was our increasing amounts of data for our clients per client. and therefore the reporting was getting slower and slower, especially when running custom queries with additional filters, which could not be cached beforehand. And this resulted in ultimately a degraded experience for our users, waiting even 35, 40 seconds to see the results of a report. And this was not acceptable anymore for us. So we started to look into an upgrade because this is the first the path of least resistance, let's say, right? You have something, it works, let's upgrade it. But there were a number of issues here because the version was that old. We had to do 4 or 5 upgrades, sequential upgrades, in reaching the latest version of MongoDB, which was 7 at that time. And from past experience, these were not going to go well. So it rarely goes well to have 5 sequential upgrades to a system, not damage any data or not hit any blocks. Furthermore, we were using an older driver as well for the MongoDB in PHP. We're a PHP shop. So there was kind of a deadlock there. We couldn't upgrade MongoDB because the old driver didn't know how to communicate with it, and vice versa. We couldn't upgrade the driver because we would also have to upgrade the MongoDB instance. There was no overlap on versions in the driver. So essentially, this rendered the path of upgrading useless, and we started to look at it as a migration. Even if it was MongoDB to MongoDB, it was still a migration. However, our data was mostly relational. When I say mostly, I mean almost entirely, like 97%, something like that. And there was always this thought that if we'd had a relational system, it could perform better than NoSQL system. So we started looking into alternatives, and we found quite a few that we examined, including time series for Postgres. We also looked at some Apache solutions. Of course, ClickHouse. I'm not sure. Even Cassandra and HBase, I think they were on the list. But most of them fell pretty quickly due to the high complexity for deploying and maintaining such a system. We're a fairly small team in regards to engineering, and we really wanted not to hire somebody dedicated for the database. So ideally, we would have the engineering team handle the deployment and maintenance of the system. What I mean by maintenance is like common operations, scaling in, scaling out, restoring backups, performing backups, first of all, right? And upgrades, because we ended up in this situation because of upgrades being hard to be made. And basically, we ended up with a very short list with TiDB and ClickHouse. And we found unanimously TiDB to be like a no-brainer to handle. The tool which handled the initial setup and which we use ongoing for maintenance is TiUp, and we have done a number of scale outs, scale ins, also replacing nodes. So we replaced the hardware on the nodes. We took down nodes one by one and replaced them with larger instances. And it all went very, very smooth. So no hiccups there. We did this also in production, not just in the POC phase. So it was kind of no competition in the end. We chose TiDB.
Cool. Cool. Yeah. I mean, obviously, we're we're flattered that you chose TiDB, and yeah, I'm not sure if I missed it. Like doing 4 to 5 upgrades, that just I mean, just sounds like really painful. Just one upgrade is hard enough, and like you said, it's very rare for upgrades to go smoothly or without issues, and then having to do that like 4 to 5 times, that's just like a really painful process. And yeah, and then appreciate sort of the selection criteria that you had, and I think sometimes people forget, like we have various toolkits that go along with TiDB, like a tie up being one of them, and we have other like a tools like TiCDC and whatnot that I don't think it gets talked about very often, but I'm glad that tie up and among other things were able to sort of streamline your migration process. So,
They definitely
yeah.
did because for our case and for anybody's case for that matter, tie-up just takes away all the complexity. You just have a YAML which specifies your topology, how the nodes should look like and where should they be deployed, and that's it. It's very, very simple to understand and then to operate.
Cool, cool. Yeah, I mean, very glad that you had good experience. And well, I guess we'll start talking about the migration itself. I mean, you talked about like you kind of referenced like a POC, before like doing this like in production. I mean, talk to us about like your approach to like migration, what you did through POCs, like what kind of plans that you have put together for like release development and even testing. Yeah, I mean, if you can sort of walk through that, I think that would be very helpful. So,
Yeah, sure. So it was clear that switching to another database was going to need some sort of prior testing and validating the system. So we went for our two biggest constraints. First and foremost, there was the pain that we had that prompted us to look for a replacement in the first place, which was reporting query times, which were very high. So we ran on in-depth analysis on this part, analyzing both simple queries and complex queries where you add filters, select custom periods, and so on. This was on one hand, and TiDB offered pretty shattering results on this test. There was 9 to 14 times as fast in terms of simple queries, and for complex queries, it could go up to 40 or 40 times. So not percent, 40 times faster. It was seconds compared to minutes. Basically, it was kind of a no-brainer to pick TiDB on this one, and the results, to be honest, far exceeded our expectations. So we went on to the second phase of the POC, which was load testing. We wanted to make sure that TiDB will support 4 to 5 times of our current traffic, meaning more than 100K requests per minute, without needing to also scale up the hardware. So this was also a very important aspect for us, the budget. So we set out to gather some real life traffic from the access logs. Then we created some scripts. We wrote them in JavaScript to be able to replicate the traffic. And we chose to use Grafana's K6 stress testing tool. We ran that from Kubernetes cluster. towards the other Kubernetes cluster, which was hosting our app. And first, we determined the let's say optimal capacity for each of the pods, like determining the resources, CPU and the memory and their ratio. And after we got some consistent results, we scaled that by 10. The point here was just to make sure that TiDB wouldn't scale aggressively with costs when it came to scaling requests. So we didn't go for a very, very in-depth and an advanced performance tuning of the requests and of the TiDB queries at that point. And we measured the results using New Relic. So we consistently had 100K requests or more, up to 120K requests at times for more than 1 hour with 0 errors, and while maintaining the response time very, very low. And what I mean by very low is under 20 milliseconds for the whole request. So not just TiDB, because the experimentation platform needs to be as real time as possible in order not to slow down the websites on which the experiments are applied. So that was a success too, and we decided to go on with the migration, and we set out a deadline of 6 months from that moment, which was pretty ambitious, but we managed to pull off in the end.
When I saw that in the presentation, I was surprised too. Like because I mean, like you said, like you don't have a huge staff, and trying to do a big project like this within 6 months was pretty impressive.
Yeah, the project was done in 2 or 3 people, depending on the moment. So at times there were 2 engineers, at times there were 3 engineers working on the project. But we wanted to go for a very, very simple approach. So not to complicate things. And on the other hand, we wanted to be absolutely certain that no data gets lost and that no queries are, let's say, broken in the process. So we wanted to make sure that data accuracy is maintained 100%. In order to do this, we decided to have a pretty large period where the systems would run in parallel. So we set out to build a minor, let's say, switch, like a mechanism of flip between the two databases, which would direct data to both TiDB and MongoDB for a period of time, and then ultimately allow us to gracefully retire the MongoDB that we had. And we did this successfully, in my opinion. We had a period for I think 2 months, 2 or 2.5 months, something like that. We basically had the systems in parallel, both ingesting data and both producing reports. And we had a number of automated scripts checking each and every query that is being made both on TiDB and on MongoDB to make sure that the results are 100% the same. Obviously, in the beginning, they were not. But after ironing out issues, we had consistent results for almost a month before deciding to promote TiDB to be the main database. So as a general timeline, we started out to import data. This was the first step. And we did this in a very simple manner. As I said, we didn't want to complicate. Basically, we wrote some scripts that exported data from MongoDB into SQL insert in batches. We did some tweaking around this to find out what batch size would be optimal in terms of time. I think for us it was around 1 million inserts per batch. This produced the best ratio on inserted rows per unit of time. After having this data in TiDB, we managed to start to ingest data from both systems. Obviously, it was a small penalty in terms of response time. We had like 5 or 6 milliseconds extra, but we decided to go with it just to make sure that data accuracy is not affected at all. And after this point, we had like MongoDB still being the primary database and TiDB being the secondary database, just for the purpose of checking things between the two. And after these 2 months, which I mentioned, we promoted TiDB to being the first, the primary database, meaning the reads would also get done from TiDB for all of our users. And we left it there for 1 month, one more month, after which we retired MongoDB completely. And therefore, we were able to also upgrade our tracking system, the system which ingests data, and upgrade to the latest PHP version.
All right, cool. Yeah, I mean, thanks for sort of walking us through, I mean, very methodically the process you went through. I mean, like I mentioned earlier, I mean, you laid this out also in your slides at the FOSDEM presentation that people should be able to check out through the links in the episode description. And some of the, like early on, when you talked about like the migration process, some of the amazing test results that you saw, like a query performance or whatnot. I mean, those are in the slides as well with nice graphs. And yeah, I was like, I mean, like you noted, like when I first saw the slides, I thought it was like percent. Like, I mean, surely that's like percentage difference, not like multiples in terms of performance enhancement. So yeah, it like the listeners and people that are watching on YouTube should be able to check those slides out when they have a chance. So yeah, and I think you mentioned some of it, like as you're going through the migration process, like what are some of the like a lessons learned or like the results that you want to share? Like if you were to I mean, hopefully you won't have to go through this like a long process again with migrations and upgrades. But if you were to do this again, what would you do? Like, what are some of the things that you would like to pay attention to, and what are some of the things that you learned through the process? Because, I mean, as we alluded to, no upgrades or migration, whether it's database or operating system or something else, it rarely goes very smoothly because I mean, it's not because people don't have the knowledge or expertise, like there's just too much details to sort of follow. But what are some of the things that you would sort of point to as something that you as sort of lessons learned during this process?
Yeah, in terms of let's say the software part, the development part, we had some charset issues. This is pretty common when migrating between various engines of databases. We thought we resolved them, but we didn't resolve them all. So we found out post-migration that there were some left, and we tackled that as well. Besides this, it's very important to read the documentation, which we did because we had experience with migrating data for large data sets within the team. For us, very surprising in terms of, let's say, output were two flags for optimizing joins and optimizing distincts. So I'm not sure how they were called, but they were something like aggregation push down and distinct push down, something like that. When enabling these, the performance was way better for our data, at least. It came down to like 2x improvement, something like that, when comparing results for enabled versus disabled for these flags. So take a look at all the flags that are available, because on the reporting side, it might make a huge difference. We analyzed all of them, but only these two produced massive improvements for us. Um, Another thing I think is that joins will not go on forever on large data sets. So when joining and joining and joining again with multiple tables, it seems like it's going to work, but after some time, the Cartesian product skyrockets the memory, so it just stops working for some data sets. And there we had to rewrite some queries and filter more data in the initial where, but this wasn't a major issue. However, a thing that I think is noteworthy is the fact that being a distributed system means that the IDs allocated to rows inserted are not necessarily in the order of insert, so they're not monotonously increasing. And we had some trouble with this in some insert and then select statements that we did in the application, but we managed to sort this out by using the timestamps. So this is something that might not be obvious at first, and for sure it will be hidden if you don't have like a fully fledged staging environment. If you're only using one node, you will not see this. I think this was one of the things that we did not expect to happen. And another lesson learned in terms of OLAP versus OLTP, it's not actually a lesson learned, it's more of a confirmation. With rising data set, the transactional part will scale linearly and then towards something like exponentially with the data set, while the column-oriented part is not that impacted by the data set. So when having large data sets, it's crucial to use an OLAP system. And for us, it works very well. So when we have like point queries or stuff that's producing or analyzing a few rows, like 100K or less, the transactional part, TiKV, is used. And when running large aggregations, we use the OLAP part, which is TiFlash, and it works really well.
Cool,
This
cool.
this
Yeah,
combination.
yeah. I mean, thanks for sharing those details. I mean, things like flags. I mean, we don't have like a two or three of them. There are lots of different flags. So it's sort of figuring out how all those work. I mean, I could certainly imagine like how. I mean, unless you've been using TiDB for a long time, I don't know how you would like a thing to check all of that. But yeah, I mean, I think the two flags. I'm cheating here and looking at your slides that you mentioned for joins, and this thing says TiDB op ag push down. I think you got that name right, and the other one has similar name, but the word distinct in there in the middle. So cool. So yeah, again, I encourage people to check out the slides. I mean, you'll find more details there. And also, yeah, I mean, and then I mean, you did a amazing job like presenting in the 10-minute slot that you like a bit of a shorter presentation window that you had. And yeah, I encourage people to check out the recording too. So Cool. So, I mean, thanks, Soren. I mean, not only being our community member and a user of TiDB, but sharing your journey with the rest of us. I mean, I think a lot of people that are migrating not just MongoDB, but other NoSQL databases may will probably find this very helpful. So. Cool. So we reached the end of the podcast, and we have a tradition. We call it the closing travel trivia. So Soren, you're joining us from Bucharest, Romania. You're the first guest that we had from Romania, and it's actually a country I've never had fortune of visiting. So I mean, I was really looking forward to the question. For somebody like me that's visiting Bucharest for the first time, like what are some of the things that you want to point out that may not be in the travel guides and that you want to point people to?
Well, I think you'll find most of the things, of the interesting things in the travel guides. But what I can recommend is for you to have walk in the old town, which is very, very nice old buildings. It's actually Bucharest is called was called back in the day Little Paris or Paris of the East due to resemblance in architecture, large boulevards, buildings, palaces, and so on. So it's a very nice city to walk through, especially in spring. And of course, visit the House of the Parliament, which is the heaviest building in the world. So it's something worth seeing, definitely.
Wow, wow, cool. It's like heaviest. Like I don't know how they measure this. They just like add the like a weight of all the
Yeah,
material that were used, or like
yeah, exactly.
yeah.
So it's a lot of marble there. It's like
Oh, okay.
4 million tons, something like that. And it's
Wow,
in terms of administrative buildings, it's second in the world after Pentagon. So
wow.
it's a lot to see there. You can visit some of the places, not all,
Right,
but
right,
it's definitely a masterpiece of engineering, and it was kind of controversial at its time because whole neighborhoods were demolished to make room for it.
right.
And let's
Cool.
say safety measures weren't top notch
Right,
during the building.
right. Cool. Well, I look for. Hopefully, I'll have a chance to visit. It sounds nice. So hopefully, I'll have a chance to visit and take a stroll, especially in spring, as you mentioned. So
Yeah, it's a
yeah,
very vibrant city. There's
yeah.
always something going on in terms of entertainment, culture, you name it. You name
Cool,
it, you have it.
cool, awesome. All right. Well, thank you, Soren, for that trivia. In addition to sharing your experience with migrating your data to TiDB. Yeah, hopefully, like maybe next year in Fawzan, we'll get a chance to shake hands again and grab a beer. Yeah, thanks for joining, and for the listeners and people that are watching on YouTube, we'll see you on the next episode.
Thank you for having me,
Yeah,
Raymond, and
yeah. Thank you, Soren. Yeah.
best of luck.
All right. Hey, you too. Thank you.